So next one, continuation of that one, but it's not related to Arrhenious theory of activated complex. It's somehow equation. We are using this equation. This is important for the examination point, not the equation. Determination of A. That equation is important for calculating or solving the problems. So look here, Arrhenious equation. What is Arrhenious equation? Arrhenious equation is nothing but is going to give the relation between K, activation energy, gas constant and temperature. Here K is a rate constant, is directly proportional to the e raised to minus e upon RT. That proportional can be replaced by is equal to by keeping some constant. That constant is nothing but A. Here A is nothing but Arrhenious constant. A into e raised to minus E upon RT. Whereas this expression is called as Arrhenious equation. So what is Arrhenious equation? Arrhenious equation is which gives the relation between rate constant, activation energy, Arrhenious factor, A is nothing but Arrhenious factor, activation energy, gas constant, R means gas constant, T is the temperature. Means activation energy is gives the relation among rate constant, Arrhenious factor, activation energy, gas constant and temperature. Whereas the gas constant R is having the value 8.314. This is the constant value we are using in problems. You should remember this one. R is equal to 8.314. So here, this is the Arrhenious equation. To determine the EA value, we are changing this equation by some alteration. Just we do the logarithm for this one. But we are not applying log, but we are applying instead of log, we are applying the ln. By taking the ln on both sides, this equation becomes ln k is equal to ln a into e raised to minus ea upon rt. Whereas this ln a into e raised to minus ea again becomes ln k is equal to ln a minus EA upon RT. I hope you remember the mathematical expression. E raised to something, e raised to something. By applying log, e raised to x, by applying log, it becomes log x to the base e. I hope you remember in this one. E raised to x is equal to log x, whichever the power is there on e, log x to the power, log x to the base e. This is how I have written here. Ln a e raised to minus e upon rt. That e comes to the ln, but we are not representing that because e is understood. It is based on e. When we converting this ln to the log, at that time we are representing ln by multiplying 2.303 as we did in the previous classes. So here, by taking ln on the both side, we are getting the expression ln k is equal to ln a minus ea upon rt. So to this expression, we are changing if this expression is varied by, if k is varies with respect to temperature. In the last expression, temperature coefficient, we observed that rate constant is depends on the temperature. As the temperature changes, rate constant also varies. So it means when the temperature is T1, then K is K1. When temperature is T2, then the rate constant is varies by T2. When T2 it is K2, when T1 it is K1. Similarly, look here, to this equation, when the initial temperature is T1, at that time ln K becomes K1 is equal to ln A as it is ln A minus EA upon RT, EA upon R. While writing T, we are writing T1 because it is at the temperature T1, rate constant is K1. Similarly, by changing it is when K is K2, it forms K2. When the temperature is T2, EA upon R T2. At the temperature T1, the rate constant is K1. When the temperature is T2, the rate constant is K2. So by this two expression, we are subtracting equation number 2 from 1 means we are taking k2 minus k1. So when we are taking k2 minus k1, at that time log k2 minus log k1, I am saying the word log instead of log. So it means log a minus log b, log a minus log b, it becomes log a by b. I hope you are getting my point. Log a minus log b, it becomes log a by b. Therefore, by subtracting 2 minus 1, we are getting log ln k2 minus ln k1. Therefore, directly I am writing ln k2 minus ln k1. Therefore, ln k2 upon k1, ln k2 upon k1 is equal to, by subtracting ln a, this is plus ln a minus ln a, means these two are cancelled each other because it will be the plus. Equation number 1 becomes minus. Therefore, plus and minus they will cancel each other. It will become 0. We are subtracting, we are not dividing. Subtracting. Therefore, these two becomes cancel each other. And remaining is minus EA upon RT. Initially, minus EA upon RT. I will write here minus EA upon RT. So look here, RT. This is T2. And here it is minus E upon RT1. Can you see here? It is minus, again here minus. Minus into minus it becomes plus. Means EA upon RT1. EA upon RT1. Look here. Ln K2 upon K1 is equal to minus EA upon RT2. RT2. The same thing. And here minus into minus it becomes plus EA upon RT1. So here in the left side it is as it is ln k2 by k1, ln k2 by k1, and right side I will take the EA is common. Here it is minus, here it is plus. So I will take the minus common, minus EA, and below it is R is common in the root. R and R it's common, minus EA upon R. Here it is minus. So together I have taken minus. Therefore, remaining is 1 upon T2. I have taken minus, therefore plus 1 upon T2. And here, instead of minus and plus, I have to write the minus. Why? Because I have taken the minus as a common. Minus into minus, it becomes plus. So I have written here plus. Why? Because minus into plus, it becomes minus. So to get it plus, minus into minus, it becomes plus. Therefore, EA is taken common, remaining is 1, and below we have taken R as a common, so remaining is T1. So while writing representation, you may get this trouble. So keep in your mind, I have taken minus EA common, and remaining that minus becomes plus, and plus becomes minus. Therefore, by applying here ln, we are converting that to the log K2 by K1. To make this lag as a log, we have to multiply 2.303 log K2 by K1 is equal to minus EA upon R, as it is 1 upon T2 minus 1 upon T1. And when we are setting 2.303 to the right side, the numerator it moves to the denominator. It becomes divided. Therefore, log K2 upon K1 is equal to minus EA divided by 2.303 R into bracket 1 upon T2 minus 1 upon T1. We may write this one as, by taking LCM, T1 minus T2 divided by T1 T2. We can write the expression in that way also. This last expression is important. This is the determination of EA. To calculate the activation energy, this expression is important. So we can see here, EA is here, but we are not getting the EA is equal to, the equation is not in the form of representing EA, but somewhere in this equation we are having EA. To determine EA, not only EA, to determine the T1, T2 or temperature of K1, K2, we are using this expression. This expression is called as the used to calculate the activation energy. Therefore, log K2 by K1 is equal to minus EA upon 2.303 R into 1 upon T2 minus 1 upon T1. This expression is important for your further problems. I am going to do the problems at the end in the next session. Okay, so this is important. So this is also important, the effect of the catalyst in the chemical kinetics. So in the chemical kinetics we have been studying that the rate of the reaction, means speed of the reaction, how it varies, what factors are influencing for the rate of reaction. Among those all factors, catalyst is also one of the most important role to change the rate of reaction. So we know that in the catalyst, wherever we are using the catalyst, obviously there is a change or alters the rate of reaction. So here catalyst is a substance which alters the rate of reaction without being consumed itself, means the catalyst do not undergo any participation in the product, but it only increase or it may change the rate of reaction. So we are using catalyst only purpose to increase the rate of reaction, not to decrease. Therefore generally we are saying it alters the rate of reaction. Obviously it increases the rate of reaction, means speed of the reactions is increases by using the catalyst. For example, the KClO3 undergo the decomposition reaction to give KCl and O2. To make this reaction, no doubt it may take more than 1 or 2 hours. At that condition, when we use the catalyst MnO2, this catalyst increases its speed formation of the product. So means it reduces the time or it reduces the activation energy required to make this reactant to form a product. How means? Look here, in the Arrhenious theory, we saw the reactants are going to form the product by giving some amount of energy. That energy is called as activation energy. So this is the activation energy. So these are the reactant and this is the product. So to make a reactant to be an activated molecules, we need some amount of energy. That minimum energy is called as threshold energy. So after getting the threshold energy, reactant will react each other to form a product. So this amount of energy is required compulsorily. So if we use the catalyst, the catalyst will reduces that activation energy. Its activation energy. So means the same reactant, it's going to be the same product, but the amount of energy required to make the reactant as active, that will be reduced. Means to supply that energy to react with the reactants to form the product, that energy will be reduced only in the presence of catalyst. If we use the catalyst will reduces the activation energy. If it is not that we are not using catalyst, we need to supply the more energy to the reactant to form that reactant as activated complex. So this is the effect of catalyst in the rate of reaction. Okay, my dear students, we are at the last concept in the chemical kinetics. In the theoretical part it is last one, but still we are having some problems. Those are important for your examination one. I will do that in the next videos. And look here last one, the collision theory of chemical reaction. So what is the collision theory explains regarding the chemical reaction. If the reaction is taking place, how they have to react with each other, how they have to react to form that, to get a particular product, whether the product forms or not. So it means they have to make some of the reaction in some of the proper bombardment or proper dashing, proper bombardment, collision means touching each other or reacting each other, that is called as collision, or bombardment means reacting each other. So how they have to react each other, that will be explained by the collision theory. Collision is nothing but which it explains about the colliding, means touching, bombarding each other. So here collision theory of chemical reaction is going to explain whether to form the reactant into the product, it should follow a proper orientation or proper bombardment, proper collide or proper effective collisions between the reactant, so that it will form the product. Otherwise the product will be not formed. So is it clear? So coming to see the example, here CH3Br means methyl bromide. Methyl bromide reacts with the nucleophile. So same again in the SN1 substitution nucleophilic reaction, you have seen these reactions. So here methyl bromide reacts with the nucleophile OH minus. Here there are two kinds of the reactions. If in this reaction bromine also carry negative charge because it is anion, bromine being a negative and OH is a negative charge. So here in this reaction OH is going to occupy the place of Br but not others. So Br is replaced by the OH molecule. So that here in this reaction if CH3, this is Br, if OH minus starts to collide this molecule methyl bromide in this direction, if OH begins to be react with the methyl bromide in this direction, means towards the Br, it means it's not possible to remove the Br because OH is also having negative charge, Br is also having the negative charge. If the OH is moving towards the Br, in that it is a Br, OH is moving towards the Br, OH is also negative, Br is also negative, the like charges repulse each other. They are not undergo the replacement. It's not possible to be a proper orientation. The proper collision do not occurs in this expression because OH has to be take place in the positive charged or positive ions towards that one, so that later we can remove the Br minus. Here, if the OH is taking attack to the methyl bromide towards Br means it's not possible. So it will undergo the breakage. There is no cleavage of CBr. Therefore, there is no formation of product. No product is formed. So this kind of attacking is called as improper orientation. Improper orientation or improper bombardment. The collision do not have the effective collision is here. So what the OH has to do to replace the Br means here CH3 Br. I hope you remember it in the SN2 mechanism. The nucleophile is going to attach to the opposite side of the chlorine, opposite side of the halogen, so that it will form the single step reaction. So similarly same kind here also, the nucleophile OH minus has to be attached to the methyl bromide, opposite side of the halogen, opposite side of the Br, either in this side or in this side. So it will be the opposite. So at that time OH will attach to the carbon and Br will be there to make the partially bonding. Further CBr means carbon to Br undergo the cleavage, OH will attack. So it will becomes CH H and this OH means methyl alcohol. Methanol is formed by the cleavage of Br minus. So this is called as proper orientation. This is proper orientation or proper collision. Effective collisions occurs in second step but not in first step. This kind of explanation is called as collision theory. Collision theory of chemical reactions explained to make the reactant as a product. To get the product, the reactant should undergo the proper collision, proper effective collision, so that it can get a stable product. If improper collision appears, then there is no formation of product. Even though it forms the product, it is unstable. We are not getting the product permanently. So I hope this is clear for you. You will be getting the notes for this and write down, and we will do the problems of this chapter very soon. Okay. If you are having any doubts, feel free to ask your doubts and try to understand this one. You may feel a little bit fast. Go through this video once again and be prompt while writing the notes and understand the concepts. Okay. We will meet in the next class. Until, have a very good day. Bye.